Welcome back to Wickerson Studios. I am working hard on hops, and I've entered a realm of actually getting into some interesting geometries, but I wanted to show you the earlier Hop2 scripts that I'm in use of, using on my GitHub that you can just apply without knowing all these C nodes and having to write all these, which came out of the Warsaw Academy. I'm basically in K-arrays right now dealing with 3D grid points. And then I'll finish up all these other methods and classes, and then I'll move on to other works that are geometric. But everything prior to this may be useful. So without having to write C#, you will be able to go into here and find a file path and go directly to what's been hopped up. This is actually on my desktop, but I will make the link directly to my GitHub. And here's one that you can actually slide through, kind of a true-false. Basically, a one slider is what you actually use, or a Boolean toggle will work as well. So an integer, it's a nice simple Boolean toggle that's been hopped to in case you want to actually use that data. Now, many of these are so simple, there's no real point in using them because there are Booleans that do this, like a Boolean toggle. But it's interesting to think of coding and scripting and what's happening here. So that's one that I'm going to keep in there just for fun. The title is Conditional Operator. The next one here is basically takes an integer and makes it converts it to a double, and the other one converts it back to a integer. So you can kind of get in here and play around a little bit. Actually, they're both converting to integer. Maybe become useful for processing data, but learning how to hop to it. And I'm really trying to get these hop nodes in use, so the scripts and Grasshopper become less wire-like and less tangled. Just give me a second to open this one up. Conditional operator. Let's go down to basic operator. Probably can chose out the other one. So this is nice. You just got addition, difference, multiplication, and division all within the same node to a certain level of accuracy. These are written obviously in these C scripts if you wanted to go down and find out where they are. This one is D1, so you can go in here if you actually wanted to get the user objects and see the basic operators coming out of the C script, and you can actually see how that's actually written in C, which isn't too hard. And I think at this point you'd be using the ribbon nodes as well. Let me just jump into here and delete a couple of these, get rid of this one. I don't need to save it. This is the next one, double conversion math round. This might be best. That's the one I did already. So I'll just get rid of that one and save it if I made any changes. There was the integer value that I was doing. It takes a little bit of time because I have a lot here. What's another one I kept? This one, just an integer division on two floats. Nice little node that you can get pretty much without having to use it, but I'm going to leave it in there because I think I kind of use it for my scripts. Basically wanting to write Grasshopper geometries by hopping to a bunch of pre-made C scripts. And this might, like I said, be interesting to some people and not so interesting to others. But for those that want to get into the ghpython nodes and the C nodes, it might be fun to try it. So I'm going to get rid of that one, save it with the change. This one's similar. Gives you an integer division and then remainder, so it's a nice little node that does both, having your first number and then dividing by the next number and leaving you a remainder as a modulus. So that one I may end up using. And I'll just take that one to, give me a second. It's just taking a second to open all the others. It'll become more quicker as we get rid of some of these. I've opened up all the ones that I think might actually be helpful. There we go, we'll close that one. Save it, and then we go to this one. This is an increment, decrement, so you're starting with your original number, you're bringing it down by y, and you're being left with the y increment, and then you can also bring it down by another one. So you can have multiple sliders, multiple gene pools. And what's nice about these scripts, they'll just run and produce lists. And so if your number sliders are here and you have some basic numbers, what I've been getting into is getting into the gene pool and starting to plug in the gene pool node to be a bunch of data. Of course, if I could just get it, you can actually deal with all these numbers, and then you're starting to bring those in, and then you're producing a huge list of as if you did. And you just have to tidy this up and think about this as driving new geometries. So I'll leave that one off. And so that's one that I think I'll use, the increment, decrement. So you can get rid of that one, save that one. Next one is strings. I probably will get rid of this one because it just turns lowercase to uppercase. Probably not so needed for driving geometries, but next one was an operator that shows a precedence. In case you forgot how to use that, you're not going to need that one for any Matthew that already knows it. This is just something that checks for similarity. So if 2 is 2, then it's going to tell you true. You could substitute these for ribbon nodes, but this is, getting your head wrapped around kind of logically what's happening. This is adding 1 to gene pool. I like this little script. So if you have to increment and just increase your geometry or step it up, and then you can use a multiplier afterwards, I think I actually will use the add 1 to each. And if you want to know what this one, you go to the DT in downloading my other nodes for Warsaw. You can go into the DT, and then you have your added item, and you could read into the script and actually see what's happening, which is pretty simple. Just adding 1 to that output item for each loop. So you get a sense of understanding that. This isn't for everybody, but it is for me currently at this time in my life. This one's kind of interesting, but I don't really need it. This is a quadratic equation, which I actually worked with Daniel Christoph, who combined a beautiful tool for solving conics and actually dealing into the quadratic. So you can jump in on many levels and solve the quadratic even more complicated than maybe what was going on here is the quadratic equation for solving for this parabola. So nice little example of maybe you want to use this one and find out the outcomes and the solutions for that. Let's get rid of that one and we'll save it if I made any changes. This one's just, it's just a true false, but it's actually kind of cool that was dealing with some script that's a little deeper with understanding braces to understand C. Not that necessary to wrap your head around. I'll probably leave that one off. But what I've done is just old school, taking a piece of paper and kept all the scripts that I think will be handy to me as I start to jive up my Grasshopper scripts by using the hops node. And so for those that are following what I'm doing, I think maybe you can follow this. This is a nice little component. It produces a series and a range in the same component. I'll definitely be producing that one because a lot of people like to compare dealing with series and ranges. That's a really nice one. And like I said, you're literally just actually hopping to these statements. This is just as X smaller than Y. You're not going to do this one as a test of learning the if statements. I'll leave that one off. This one is obviously popping it into a gene pool and solving for it, so you're not going to need that one either, I don't think. This one's talking if you can vote in the election. You're not going to need these, all dealing with text and the else if statements. And then this one's not bad. I might actually use it. I might want to know the and or not A or not B, so I might filter through some data on Booleans. Certainly if it's a set of data that's ones or zeros, so I'll get rid of that one. And then here I've got a case switch, which is just moving it up from A to B to C. Not going to use that one because that's hard-coded in to solve something. And then I have the iterations and loop count, which is nice. I might use iterations, which gets you away from using loop snake or enemy. So I might keep that one going. Pseudoscript loops. There's a lot of loops in here I may use, I may not. This one probably not. Keep in mind that you can always jump to the path, get it on GitHub and input it here, or find it on your desktop. This is nice because it's just telling you if it's an even number or not, which means you can do that within a number slider or param. It's a nice little node that custom does that for you. And this is for those people that are tired of kind of static modeling and want to use parametric controls and push it into computational studies. This is a break continued with loop as a component message, and once again, it's just if it's less than this number, will that run that series? So this is a little function or node I might find helpful. There's a lot in here when it comes to the loops, and I'm just going to fly through them. They're all the kind of F series. You can work them with gene pools, which is nice. I can go into G, which is dealing with while loops, pretty basic stuff. But for Grasshopper not to have this, this is always nice to script it in there, and maybe for people that don't want to get into the details of C. So a while loop with break, that's pretty simple. And then I have another one, do while loop. While this is the maximum number, it'll start counting. So you have to be careful with these that you'll get into an infinite loop and crash your computer. Then I've got one tool here, which is go to return instructions. Let's see if I play enough of that. It basically will take that number. Yeah, it'll just be like a number slider between a couple of sliders. So if a number X can go to this number, it'll keep going up until it gets to this number. Not a very functional, important script, but it's there all the same. An exit loop would go to, so we'll exit the loop. I like this one because it's a countdown tool. So if you're thinking of downsizing or scaling smaller and smaller, you could set this to very small increments, but it only works by integers, so you can't really use points. You have to use a divider afterwards to make it work. Checking special conversions. This one's probably not that necessary, but it's actually starting to deal with how to, the script for this one J01, you probably want to go back into the Warsaw, check out J and see what's exactly going on in that C script. And it's probably a lot more complex than you think. Yeah, a little bit of script writing, and that would be for the one that wants to do their homework, advanced or intermediate. We're almost through the series. I'm going to save that one. Special conversions, again, I probably won't use that one. I didn't put it down as my top one. This produces an empty array. Can't say I'll be doing that. The polyline set to null, and then the empty polyline. This was interesting because when I did pop it up, it wasn't working as well as the polyline was working here in the C node. This one actually takes the count and produces a little different data in the array. So it produces 3 null arrays, whereas this one just comes out and produces 1. So there's something happening funky with the hops there that I'll have to figure out. Now we're getting into some geometry, so they're starting to drive. I like this one because it does produce the series, and you can have some control and see some data coming out of the out node. Sometimes I have the out node working in hops just to allow you to kind of debug and think about what's going on behind the scenes. And then we enter into the top script that I'm going to start going geometrically involved. We will go in here and hit open, and I'm down here moving through and getting to the 3D grid of points, which is wonderful to open that one up. And as long as I can get my picture out of the way, I can click it. You can see that this beautiful node is actually entering the Rhino window that I can go in and grab my 3D grid of points and start having some really nice computational C scripting, which is just a nested loop of actually making this and being the points that are driving the geometry. And here's where things are really going to kind of move into intermediate and advanced for those that want to get computationally working with static modeling. And I will just continue through this and jump into the range, the grid of points with the multidimensional array, and then another creating an array of 3D points and then filling that array. And obviously following that up with those arrays, I'll follow jumping into lists, methods, classes, and some basic exercises. After that, we'll jump into Rhino geometry from Rhino-Lysis. So I hope that's informative. This 12 minutes, a lot of information, and kind of putting you into my mindset, and hope you find it valuable. Thanks.